I've got a real-world maths puzzle for you. You can tell this is a real-world maths puzzle because I'm only going to talk about the limits of infinite sequences right at the end, up until completely real-world. So this puzzle is about fireworks. Do you remember fireworks night? You'd all go outside and huddle together as you cheer on particles being flung theatrically towards everybody. Completely the opposite of life at the moment. So suppose you want to put on a fireworks show. You've got all your fireworks, but the fuses you've got are pretty badly made. They each burn for exactly 1 minute, but they're quite irregular. You don't know how much will have burnt off after 30 seconds or 45 seconds. After half a minute it might be half gone, or nearly all gone, or hardly gone at all. So you can set off a firework in a minute's time quite easily. Just attach one end to a firework and light the other end in a minute. But you want to put on a proper fireworks show. You want to have a load of fireworks going off leading up to a big finale where a particular firework goes off. But here's another real-world maths problem wrinkle. You've forgotten your watch. You've got no way of telling the time apart from using these fuses. That happens. Sometimes you forget your watch. So, how do you do it? Well, what happens if you light both ends of a fuse? If you light both ends of the fuse, they'll both burn away and they'll meet somewhere, maybe not in the middle because it doesn't burn regularly, but they'll meet at exactly 30 seconds after you've lit them. I'll leave that as an exercise for you to prove. So you can set off a firework in a minute's time or 30 seconds time. What else can you do? I reckon you could do 45 seconds. Now, if you're a certain kind of person, you might want to stop the video now and have a think about this and maybe work out a method for doing it yourself. But if you're like me, you've just left the video going and I'm about to tell you. No judgment. So here's what you do. You get 2 fuses. One of them you light both ends and the other one you light one end. This all happens instantaneously. So after 30 seconds the first fuse has burnt out. The second fuse still has 30 seconds to go. At that point you light the other end of that second fuse and in 15 seconds the 2 ends will meet. So that's 30 seconds plus 15 seconds equals 45 seconds. So that's how you do it. Now that's quite a nice puzzle on its own. Takes a bit of thinking to come up with. I think if you know it's possible, it's a lot easier to come up with a solution than if you don't know if it's possible. But now let's be mathematicians and absolutely generalise the life out of this problem. Sure. Can we describe all of the times that you can measure with these fuses? Let's call these fusible numbers. Somebody else already has, so stick with that convention. It might help to draw a number line. Here we go. Zoop. So there's time 0, there's time 1, and we know that we can measure half a minute, and 45 seconds is 3/4 of a minute. In fact, we can generalise that strategy from the 45-second solution to say if we can measure time t, so let's say we've got t here, then we can measure half the remaining time again, up there. So since we already know 3/4, we can do half the remaining time, so that's another 1/8. We can do 7/8, and half again, 15/16, and so on. A load of times getting closer and closer to 1. And normally in these kind of situations where you're taking a limit as things are going on infinitely, the limit doesn't exist.
The limit does not exist.
But in this case it does. You can measure a minute by lighting one end of a fuse. Got one more puzzle for you. How do you measure a time between a minute and a minute and a half? I'll let you think about that. Or if you want spoilers, you can look up the papers by Jeff Erickson and collaborators who have gone into a frankly indecent level of detail looking at the set of fusible numbers, proving all sorts of maths that you would not expect to turn up. In fact, there's a recent paper which shows that there are some statements in piano arithmetic, sort of a really good model for arithmetic, which are true but can't be proven just using piano arithmetic, but which can be proven using fusible numbers. So they're pretty cool.